Good morning students. Today we are going to see about design of FIR filter using Hamming window. Our problem is the desired response of low pass filter is HD of e power j omega is equal to e power minus j 3 omega. Omega lies between minus 3 pi by 4 to 3 pi by 4 and 0 otherwise. Determine transfer function h of z for m is equal to 7 using Hamming window. Okay, here for designing IAR filter or designing FIR filter using Hamming window consists of 7 steps. Okay, first given data. Here the given data is m is equal to 7. That is n is equal to 7. The length of the filter is equal to 7. Step 1. Choose desired frequency response of filter, that is HD of e power j omega, that is given in the question. Therefore, the HD of e power j omega is equal to e power minus j 3 omega. Omega lies between minus 3 pi by 4 to plus 3 pi by 4. Okay, next step 2. Find the value of tau. Tau is equal to m minus 1 by 2. That is a formula. M is equal to 7. That is given in the question. Therefore, tau is equal to 7 minus 1 by 2 is equal to 6 by 2. Therefore, tau is equal to 3. Next step 3. Find unit sample response HD of n. The formula for finding unit sample response HD of n is equal to 1 by 2 pi integral minus pi to pi HD of omega e power j omega n d omega. Therefore, is equal to 1 by 2 pi. Here the limit is minus 3 pi by 4 to 3 pi by 4. So, integral minus 3 pi by 4 to e power minus j 3 omega into e power j omega dn d omega. Okay, here the omega and j constant. So, take omega and j outside. Therefore, HD of n is equal to 1 by 2 pi integral minus 3 pi by 4 into 3 pi by 4 e power j omega n minus 3 d omega. Next we have to integrate that terms. Integral e power ah is equal to e power ah by a. Therefore, HD of n is equal to 1 by 2 pi into e power j omega n minus 3 by j into n minus 3. And the limit is minus 3 pi by 4 to 3 pi by 4. Next we have to apply the limit for omega, upper limit minus lower limit. So therefore 1 by 2 pi into j into n minus 3 into e power j into n minus 3 3 pi by 4 minus e power minus j into n minus 3 into 3 pi by 4. Okay, after neglecting the similar terms, we get HD of n is equal to 1 by pi into n minus 3 e power j n minus 3 3 pi by 4 minus e power minus j n minus 3 into 3 pi by 4 by 2j. Okay, the term present in the bracket, that is e power j theta minus e power minus j theta by 2j equal to sin theta. Okay, here the theta is nothing but 3 pi by 4 into n minus 3. So therefore, HD of n is equal to sin 3 pi by 4 into n minus 3 divided by pi into n minus 3. Okay, here we have to substitute the various value of n. That is n is equal to 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Here the value of n is equal to 3 is not suitable for HD of n. Because if we substitute n is equal to 3 means we can get HD of n is equal to sin terms divided by 0, that is equal to infinitive. So we have to separately find the value of HD of 3. Okay, therefore HD of 3 equal to, here in HD of n 1 by 2 pi integral minus pi to pi HD of omega e power j omega small n into d omega. Here in n we have to substitute the value of n is equal to 3. Okay, so therefore HD of 3 equal to 1 by 2 pi integral minus 3 pi by 4 to 3 pi by 4 e power minus j 3 omega into e power j 3 omega d omega. Okay, here same, here omega and 3 e power minus j 3 omega as well as into e power j 3 omega. Okay, so e power 0 is equal to 1. Therefore, HD of 3 is equal to 1 by 2 pi integral minus 3 pi by 4 to 3 pi by 4 d omega. Okay, by integrating that terms we get omega. Integration of dx is equal to x. Therefore the integration of d omega is equal to omega, and the limit is 3 pi by 4 minus 3 pi by 4 to 3 pi by 4. Upper limit minus lower limit. Therefore 1 by 2 pi into 3 pi by 4 plus 3 pi by 4, that is 6 pi by 4. Okay, therefore we got hd of 3 equal to 0.75. Okay, next we know that hd of n is equal to hd of m minus 1 minus 1, that is order of the filter. Okay, here m is equal to 7, so therefore hd of n is equal to hd of 6 minus n. Okay, here m is equal to 7, so therefore the n lies between 0 to m minus 1. So 0 to 7 minus 1, therefore 0 to 6. Okay, so when we are substituting these values in first equation, that is hd of n is equal to hd of m minus 1 minus 1, we got hd of 0 equal to hd of 6, hd of 1 is equal to hd of 5, hd of 2 equal to hd of 4. Okay, therefore for hd of 0 we have to substitute the n values equal to 0. For the impulse response, hd of n is equal to sin 3 pi by 4 into n minus 3 divided by pi into n minus 3. Okay, so by substituting 0, hd of 0 equal to hd of 6. Therefore sin minus 9 pi by 4 by minus 3 pi is equal to 0.075. Same as for n is equal to 1, hd of 1 is equal to hd of 5, we got minus 0.159. For n is equal to 2, hd of 2 is equal to hd of 4, that is sin minus 3 pi by 4 pi minus 1 pi is equal to 0.225. Okay, therefore, and for n is equal to 3, we already found that hd of 3 equal to 0.75. Okay, this all about step 3. Next step 4. Okay, here we have to choose our window function. Here in the question it is given as Hamming window. Okay, so the Hamming window function, the formula for Hamming window function is wh of n is equal to 0.54 minus 0.46 cos 2 pi n by m minus 1. Okay, here the limit is also 0 to m minus 1, that is 0 to 7 minus 1, that is 0 to 6. Okay, here also we have to find wh of 0 to wh of 6. Here also the condition is same, wh of 0 equal to wh of 6. Okay, for this we have to substitute the value of n is equal to 1, n is equal to 0. Okay, so wh of 0 equal to 0.54 minus 0.46 cos 0. Cos 0 is 1, therefore 0.54 minus 0.46 equal to 0.08. As well as for n is equal to 1, wh of 1 is equal to wh of 5 is equal to 0.31. For n is equal to 2, wh of 2 equal to wh of 4 is equal to 0.77. For n is equal to 3, wh of 3 equal to 1. Okay, this is all about step 4. Next step 5. Okay, in step 5 we are going to finding the impulse response. Okay, or filter coefficient. The other name for h of n is filter coefficient. Okay, the formula for h of n is equal to hd of n into wh of n. That hd of n we found in step 3 and wh of n we found in step 4. Okay, therefore h of 0 equal to h of 6, that is hd of 0 into wh of 0, that is 0.75 into 0.08 is equal to 0.006. Next for n is equal to 1, h of 1 is equal to h of 5, that is equal to hd of 1 into wh of 1, that is equal to minus 0.159 into 0.31. Next for n is equal to 2, h of 2 equal to h of 4 is equal to hd of 2 into wh of 2. For n is equal to 3, h of 3, that is hd of 3 into wh of 3. Okay, thus we found the impulse response, that is h of 0, h of 1, 2, 3, 4, 5, 6. Okay, next we have to find the frequency response. that is step 6. Okay, that the frequency response h of e power j omega is equal to summation of n is equal to 0 to m minus 1 h of n into e power minus j omega n. Okay, here the value of m is equal to 7. So the limit is n is equal to 0 to 6. Up h of n into e power minus j omega n. So here we have to put the impulse response value 0 to 1. Then summation. So h of 0 plus h of 1 into e power minus j omega plus h of 2 into e power minus 2 j omega plus h of 3 into e power minus j 3 omega plus h of 4 into e power minus 4 j omega plus h of 5 into e power minus j 5 omega plus h of 6 into e power minus 6 j omega. Okay, next here we substitute the value of h of 0 to h of 6. Okay, so only we got 0.006 minus 0.04729 e power minus j omega plus 0.17325 e power minus 3 j omega. Okay, by substituting all the value, here the common term is e power minus 3 j omega. Okay, take that common term outside. Finally we got 0.06 e power 3 j omega minus 0.04929 e power 2 j omega plus 0.17325 e power j omega plus 0.75 plus 0.17325 e power minus j omega minus 0.04929 e power minus j omega plus 0.06 e power minus 3 j omega. Next, take common terms outside. That is, in first terms 0.06 is common. While taking 0.06 outside, we can get 0.06 into e power 3 j omega plus e power minus 3 j omega. Next, minus 0.04929 into e power 2 j omega plus e power minus 2 j omega plus 0.17395 into e power j omega plus e power minus j omega plus constant, that is 0.75. Next, e power j theta plus e power minus j theta equal to 2 cos theta. Okay, therefore e power minus 3 j omega equal to 0.06 into 2 cos 3 omega minus 0.04929 into 2 into cos 2 omega plus 0.17225 into 2 cos omega plus 0.75. Next, multiply the constant with 2. Finally, we got magnitude is equal to determinant of h of e power j omega equal to 0.012 cos 3 omega minus 0.0958 cos 2 omega plus 0.3465 cos omega plus 0.75. Next, phase equal to e power minus 3 j omega. Therefore, phi of omega equal to 3 omega. Okay, these are about the frequency response. Next, finally, transfer function, that is h of z. Okay, to find the transfer function h of z is equal to summation of n is equal to 0 to m minus 1 h of n into z power minus n. Here the m is equal to 7. Okay, so therefore 7 minus 1 6. Our summation of n is equal to 0 to 6. And here we have to substitute the various impulse response values, that is h of 0 to h of 6. And by taking the common terms outside, we can got the transfer function h of z. That is h of z is equal to 0.006 into 1 plus z power minus 6 minus 0.04929 into z inverse plus z power minus 5 plus 0.17325 into z power minus 2 plus z power minus 4 plus 0.75.